Wind power is one of the most promising sources of renewable energy, but it also faces some challenges, such as the environmental impact, noise, maintenance and cost of conventional wind turbines. To overcome these limitations, some innovators have proposed a new concept of wind energy generation: bladeless wind turbines. What are bladeless wind turbines? Bladeless wind turbines are devices that can harness the kinetic energy of the wind without the need for rotating blades or other moving parts. They are based on the principle of vortex shedding, which is the phenomenon that occurs when a fluid flows past a bluff body, creating alternating vortices on both sides of the body. These vortices exert a periodic force on the body, causing it to oscillate. One example of bladeless wind turbine is the Bladeless, a Spanish startup that has developed a slender vertical cylinder that wobbles back and forth in the wind. The cylinder is fixed at the base and has an elastic rod at the top. The rod is tuned to resonate with the natural frequency of the cylinder, which depends on its shape, size and material. When the wind speed matches the natural frequency of the cylinder, a phenomenon called vortex-induced vibration, VIV, occurs, and the cylinder oscillates with large amplitude. This vibration is then converted into electricity by a linear generator at the base of the device. Another example of bladeless wind turbine is the Saphan Zero Blade, a Tunisian company that has created a sail-shaped device that follows a figure-8 pattern in the wind. The device is attached to a central point by flexible arms that allow it to move freely. The movement of the device creates a pressure difference between its two sides, which drives a hydraulic piston at the central point. The piston then pumps hydraulic fluid to a generator that produces electricity. What are the applications of bladeless wind turbines? Bladeless wind turbines can be used for various applications, such as on-site generation. Bladeless wind turbines can be installed in urban and residential areas where conventional wind turbines are not suitable due to their visual impact, noise and space requirements. They can also complement solar panels to provide energy during the day and night. Remote areas. Bladeless wind turbines can be used in rural and isolated areas where grid connection is not available or reliable. They can provide power for lighting, communication, water pumping and other basic needs. Offshore platforms. Bladeless wind turbines can be deployed in offshore locations where wind speeds are higher and more consistent than on land. They can reduce the dependence on fossil fuels and diesel generators for offshore operations. What are the advantages and disadvantages of bladeless wind turbines? Bladeless wind turbines have some advantages over conventional wind turbines, such as reduced environmental impact. Bladeless wind turbines do not pose a threat to birds and wildlife, as they do not have spinning blades that can cause collisions or injuries. They also have lower carbon footprint and material consumption than conventional wind turbines. Reduced noise. Bladeless wind turbines operate silently or with very low noise levels, as they do not have mechanical parts that generate friction or vibration. This makes them more suitable for urban and residential settings where noise pollution is a concern. Reduced maintenance. Bladeless wind turbines have fewer components that can wear out or break down, which reduces the need for inspection and repair. They also have lower operating costs than conventional wind turbines. However, bladeless wind turbines also have some disadvantages, such as lower efficiency. Bladeless wind turbines have lower power output and efficiency than conventional wind turbines, as they capture only a fraction of the wind energy available. They also have lower capacity factor, which is the ratio of actual energy produced to the maximum possible energy output. Higher sensitivity. Bladeless wind turbines are more sensitive to changes in wind speed and direction than conventional wind turbines, as they rely on resonance to achieve optimal performance. They may not work well in turbulent or gusty winds, or in regions where the wind speed varies widely. Limited scalability. Bladeless wind turbines are more suitable for small-scale applications than large-scale ones, as they have limited size and power potential. They may not be able to compete with conventional wind farms in terms of cost-effectiveness and reliability. Bladeless wind turbines are an innovative alternative to conventional wind turbines that offer some benefits in terms of environmental impact, noise reduction and maintenance reduction. However, they also face some challenges in terms of efficiency, sensitivity and scalability. They may not be able to replace conventional wind turbines entirely, but they may complement them in certain applications and niches where they have an edge.